Hello students, welcome back to ComSci 127 Lab. For the previous videos, we talked about ER model and enhanced ER model. In this video, we will talk about converting these models into relational tables. At the end of this video, you should be able to identify the components of a relational table and convert an ERD to its equivalent relational table. Relational model. It represents database objects as a table. Each table represented a set in which several operations can be performed. As you may recall from our first video, na-mention natin itong relational model as a common model used in DBMS. We have four parts in relational table. We have relation. This is the table consisting of rows and columns. Attributes, which are the table's columns. Tuples, which are the rows. And key, same as the key attribute in ERD. And then we have a special type of key that we call surrogate key. These are row ID or sequential numbers. To recall lang, ganito natin nire-represent ang entity and attribute sa ating ERD. But in a relational model, we call this whole table as the relation. It looks like a typical table. We have rows and columns. Now let's take note of the parts of our relational table. The column headers are called the attributes. And then each row, we have tuple. So, row 001 is a distinct tuple, row 002 is a distinct tuple. Basically, these are the elements of our relation. Then we have a special column that we call the key attribute. So similar sa ating ERD, this is the identifying attribute. And then we have special type of key which we call surrogate keys. These are the row IDs or sequential numbers. Advantage in using surrogate key is we can make sure that all of the tuple will have a distinct key. How do we write relations? Relations can be represented without the tuples and just the column headers. So we can write our previous example as car, and then we enclose the attributes in parentheses, and then we write the attributes separated by a comma. So we have ID. Similar to ERD, we still put underline to our primary key. So ID naka-underline siya, solid line. We have model, make, and year. So kung maraming attributes yung ating relation, marami rin yung ilalagay natin dito sa loob ng parentheses. And then we have two types of keys. We have primary key, identifying attribute of every instance. The value of a PK is unique for every instance. Primary keys are underlined in the relation. So similar lang siya ng context ng primary key as we discussed in ERD and EERD. Now the second one, ito medyo bago to, this is the foreign key. This is an attribute placed in a relation to reference another relation's primary key. Foreign key are italicized in a relation. Yung foreign key daw, for example, you have a table that references another table. So we use foreign key. Yung foreign key na yun ay nakamap doon sa primary key nung isa pang table. Translating ERD to relational model. Now, ERD or EERD are very good in providing us abstract and conceptual view of our problem and our data. It shows relationship between entities, the attributes, constraints, so on and so forth. Now, in this particular part of our video, we will translate ERD to relational model. A relational model will give us a structure or a model that is more readable and we can possibly use for our database implementation. So here are the steps or rules that we can use as a guide in translating ERD to relational model. So step 1, an entity is automatically equivalent to one relation only if the entity has no multi-valued or complex attribute, and the cardinality of the entity with another entity is not one-to-one, and the entity has no total participation with another entity. Some notes lang in translating entities and attributes into relational tables. Atomic attributes are automatically equivalent to one column in our table. But for composite attribute, they're composed of atomic attributes, for example, address, broken down into municipality, province, and barangay, something like that. We represent each of the atomic attribute, composing the composite attribute as separate column. So if we have address broken down into province, barangay, municipality, we have 3 columns for our relation. And then for our derived attribute, we don't usually add derived attribute as a column. Since derived attribute nga siya, we can just calculate or derive the value from other attributes. So we don't usually add it as a column. To illustrate, we have your entity customer. And then we have the set of attributes customer ID, which is our primary key, birthday, sex, name, and then we have your derived attribute age. So representing this in a relational model, we can create a relation customer that represents the entity. And then all of the attributes will be translated as a column header. So we have customer ID, which our primary key, still naka-underline pa rin si primary key. And then we have name, birthday, and sex. And as you may see, hindi natin in-include si age because it is a derived attribute. So we can just get it from the birthday. Step 2. Create a new relation for every multi-valued and complex attribute, and include the primary key of the original relation. In the new relation, both the multi-valued or complex attribute and the primary key are underlined since their combination makes the instance of the relation unique. So, paano naman kapag meron tayong multi-valued or complex attribute? Similar to our step 1, gagawan pa rin natin siya ng sarili niyang relation. So we have your customer and our attribute, meron tayong customer ID which will be our primary key, name, sex, and birthday. And as you may see, hindi pa rin natin in-include yung age na derived attribute, and then hindi rin natin sinama si number, which is a multi-valued attribute. But instead, we created a separate relation. So we have your customer number. Ang attribute na ilalagay natin is number and customer ID. Customer ID which will reference the original relation. So bakit hindi natin pwedeng isama si multi-valued doon sa original relation? Because since it is a multi-valued, ibig sabihin yung isang customer can designate multiple numbers. So to keep track of those data, kailangan natin ng separate relation. Because kung isasama natin siya as attribute ng original relation, there's a possibility na hindi natin ma-accommodate lahat ng data. Step 3. If the cardinality between two strong entities is 1 to many or many to 1, the primary key of the one side must be copied into the relation of the many side as a foreign key. So, kung meron tayong dalawang entities na 1 to many or many to 1, ano daw ang gagawin natin? Gagawa natin sila separate ng relation. For this example, we have series has episode. So, sa series can have many episodes. So we have here a relation series, and our attributes, we have series ID which is our primary key, we have title and description, and then we have another entity represented in this relation episode, episode ID, title, and duration. And then nagdagdag tayo ng isa pang attribute which is the series ID. And as you may notice, itong series ID na ito is the primary key of our series relation. So itong series ID na nandito sa loob ng episode relation is also called as a foreign key. So this references the primary key of series to show the relationship of these two. Step 4. If the cardinality between two entities is many to many, a new relation is created with its name similar to the relationship type. The attributes of the new relation are the primary keys of the two entities and relationship attributes of the relationship if any. So previously, ang pinag-usapan natin is 1 to many or many to 1. Ngayon naman, many to many yung relationship. So ang gagawin daw natin, we will also create relation for each of the entity. In this example, we have student enrolled in a course. And a student has a name, student ID, birthday, and a course has course ID, title, and unit. And then, ang ating relationship type is enroll. And meron tayong attribute sa relationship na ito. We have date of enrollment. For the cardinality, this is a many-to-many. So, ang rule daw, magde-declare tayo ng relation for each of the entities. So, we have student, which will have student ID, name, and birthday. Again, student ID ang ating primary key. That is why it is underlined. And then we have course. Course ID ang ating primary key, title, and unit. And then we created a new relation and rule that represents the relationship. And then, ika-copy daw natin yung primary key ng dalawa, and then kung merong attribute yung relation. So, student ID, course ID, and date of enrollment. Now, in this way, makikip track na natin yung many-to-many relationship ni student and course. Step 5. For entities with one-to-one cardinality, check first the participation constraint of the entities. So, paano naman kapag one-to-one? So, iba-iba yung rule depende dun sa participation constraint. First, if the participation constraint is both partial. Tandaan nyo pa ba kung ano yung partial? So, hindi sila required mag-participate doon sa relationship. Create a relation for each entity and still separate multivalued and complex attributes. Another relation is produced based on the relationship between the entities. So, we have here plant planted on a pot. So for example, we're working on a garden inventory system, and then ang business logic natin, plant can only be planted in one pot, and one pot can only accommodate one plant. And this is partial participation, meaning a plant can just be planted on a soil, walang pot, or a pot can just be stacked on a shelf, walang plant na nakatanim sa kanya. So in this case, we have a one-to-one relationship and then partial participation. So what we do is, magde-declare tayo ng relation for each of the entity. So we have your plant ID, our primary key, common name, scientific name, height, and type. Kinuha lang natin yung attributes niya. And then pot ID, material, height, width, and length. Then after that, we need to represent the relationship. So what we did is we created another relation, planted. And ang attributes niya ay yung ID ng dalawang entities. So we have plant ID and pot ID. Now, continuation ng ating step 5 for entities with one-to-one cardinality. If one partial and the other is total, ibig sabihin magkaiba sila ng participation constraint. The primary key of the partial side will be added in the relation of the total side. This is similar to what is done in one-to-many or many-to-one cardinality. Dito naman, kapag one-to-one yung cardinality pero isang partial, isang total, yung daw primary key ni partial ay ilalagay natin doon sa total. So third, if both have total participation, so one-to-one cardinality sila pero total participation parehas, then we produce only one relation, merging the attributes of the two. So, ang gagawin natin dun sa dalawang entity, pagko-combine lang natin yung attributes nila to form one relation. So, we have your country has flag. So, based on our rules, i-merge natin lahat ng attribute and we'll only create one relation. So, we have your country underscore flag, and then we merge the attributes. So, we have country name, flag name. So, I included the entity name sa start kasi magkapangalan sila ng primary key. And both of these two attributes will compose our key for this relation. The naming convention really depends on what you're using in your team. So for this particular example, we use country underscore flag. And then we'll just let all the attributes copied as is into this relation. Ang goal naman ng ating diagram is to communicate the design with other people you're working with. So for standardization, we follow the convention. Moving on to step 6, if we have a weak entity type, recall lang natin yung weak entity type are dependent on an independent entity type. So create a relation for the weak entity type with its attributes. Multivalued and complex attributes still need to be separated from the relation. The primary key of the strong entity having a relationship with the weak entity is added as its attribute. The primary key of the strong entity type and the partial key of the weak entity type comprise the weak entity type's relation key. So example, a student may or may not own a pet. So, ang gagawin natin, we will declare a relation based on the strong entity. So we have your student, and then primary key, student number, name, birthday, and sex. And then we will also create a relation for the weak entity. So we have pet, and then, sabi, yung primary key daw ng independent entity, ikakopy natin as attribute dito sa loob ng weak entity. So we have name, and then student number, referencing the student entity. And then, ilagay lang natin yung iba pa niyang attributes. We have type and breed. And then ang primary key nito is the combination of the primary key of the independent entity or the strong entity and then the partial key of the weak entity. Step 7. In cases where there is an aggregation, rules from the previous step still hold, and the entity having a relationship with the aggregated entities, the primary keys of the aggregated entities should be used together as a reference. So we have here an aggregation. We have here student inquires on a course offered by a college. So to translate this into relational tables, let's start dito sa loob ng ating aggregation. So we have here college offers course, which is in one-to-many cardinality. So similar to our previous rule, we'll just copy the primary key, which is college ID of entity college, doon sa relation ni course because the course has the many side. So kakopy natin yung one side doon sa many side. So we have your relation college, college ID, primary key niya. And then we have course, course ID, primary key niya. And then we use college ID to reference entity college as a foreign key. And then for the student, we just create a relation for student with primary key student number. And then since it has an association which is many-to-many cardinality, we'll create a separate relation for that, similar to our earlier rule. So we have your inquires. And then for the keys, we have your student number. And then we will also include the IDs of both entities inside the aggregation. So we have college ID and course ID. And then meron tayong attribute doon sa ating relationship. We will also add that as attribute in this relation. And then for the key of this relation, all of them are included in the key. For the succeeding slides, we will talk about translating specialization or generalization to relational model. Now, I will introduce to you different ways on how we can translate specialization from our EER diagram to relational model. So, first option, so we have here, this is applicable for any specialization, whether it's a total or partial specialization, or disjoint or overlapping. So it says here that create a relation for the parent entity and one relation for each of the sub-entities. Each sub-entity relation would contain only the primary key of the parent entity and its local attribute. So as we may recall sa specialization, we have the context of superclass and subclasses. To illustrate, for example, we have your entity performer with attributes performer ID, which is the key attribute, name and birth date. And we also have here subclasses, singer, writer, actor, dancer. And for each of the subclass, they have distinct attributes. For the constraints, this is a partial specialization and overlapping. So one performer can take different subtypes. So ang pwede daw natin gawin is to define a relation from the superclass. So we have your performer. And then we get the attributes. Performer ID, underline, this is our primary key, the name, and the birth date. And for each of the subclasses, we will declare a relation. So we have your singer, actor, writer, and dancer. And as you may notice, naglagay tayo ng primary key similar to the superclass. And alongside that, we also included the specific attribute for each of the subclass. So ito yung isang method. This is applicable again for total or partial and disjoint or overlapping. So basically any type of specialization. Now, step 9. Our option B, kapag yung specialization natin is total and disjoint. Total dapat, kapag sinabing total, lahat ng members ng ating superclass should be part of the subclass or should be classified into subtype. And disjoint meaning hindi pwedeng mag-take ng more than one subtype or subclass yung ating element. So what we can do now is create a relation for each of the sub-entities carrying along the attributes of the parent entity. The parent entity will not have its own relation. So, paano yun? So, using the same example, ibahin lang natin yung constraints para mag-fit in dun sa ating problem. So, example, yung performer natin now has a total specialization and disjoint na siya. Meaning, lahat ng performer dapat na-classify in exactly one of these subclasses. So, ang pwede daw natin gawin in that case, hindi na tayo magde-declare ng relation for the superclass performer. But instead, we can declare specific relation for each of the subclasses. So we have here singer, writer, actor, and dancer. Ang primary key niya, similar doon sa primary key ng superclass. And then, na-carry over din lahat ng attribute ng ating superclass. So we have performer ID, name, birth date. And then, idadagdag lang natin kung ano man yung special attribute ng ating subclass. Now, step 10, or for the option C. Again, specialization, ito naman applicable siya to either total or partial specialization, pero disjoint pa rin siya. What we can do is to create one relation that would include all the entities, an additional attribute T, which corresponds to the attribute that discriminates the sub-entities. So, ano ibig sabihin niya? To illustrate, again, we will use the same example. Si performer now has a total participation and disjoint, meaning, again, lahat ng elements ni performer should be part of exactly one subclass or subtype. So, isang alternative that we can do is mag-define tayo ng isa lang na relation. In this case, let's say performer. And then we have the attributes of the performer entity, performer ID, which will be our primary key, name, and birthday. Kung meron tayong attributes for all of the subclasses, what we need to do is to append or idagdag natin siya doon sa attribute list or doon sa ating column names. So we have vocal range, writing style, number of awards, and dance genre. And then sabi doon sa ating rule, magdadagdag tayo ng attribute T, which corresponds to the attribute that discriminates the sub-entities. So kailangan natin ng way para malaman natin kung anong subtype or subclass siya kabilang. So in that case, we added classification as another attribute. So this classification will be the discriminator, or ito yung attribute that will distinctly identify the performer into which subtype or subclass it belongs. Now, step 11 or option D. Specialization, applicable ito sa total or partial and disjoint or overlapping. Basically, any specialization. Similar dun sa ating una. But this one is commonly used in overlapping. And then may kita nyo kung bakit. A single relation can be created with all the attributes of the parent entity and the sub-entities. Ibig sabihin, i-merge ulit natin siya sa isang relation. A type flag attribute for each of the sub-entities need to be included as well. As an example, using again the same problem but now total participation C performer but overlapping na yung constraint. Meaning, a singer can now take other subclass. So, pwede siya maging writer, actor, or dancer at the same time and any combination of it. So, sabi dito, pwede daw tayong mag-declare ng isang relation lang and then all of the attributes will be merged. So, we have performer ID, which will be our primary key, and then name, birthday, and then idugtong lang natin yung mga attributes from all of the subclasses. So, we have vocal range, writing style, number of awards, and dance genre. And then we also have to include a flag attribute. This flag attribute will be the marker kung itong element na ito is part of the subclass. So, for example, we have here is singer. So, maybe we can put a true or false value. Is writer, true or false value. Is actor, true or false value. Or is dancer, true or false value. So, as I've mentioned earlier, this is commonly used or more practical to use in an overlapping constraint. Kasi, for example, if you have a performer which is a singer and a dancer at the same time, you can just set the value to true or 1. Pwede rin naman siyang gamitin sa disjoint. Kaya, wala naman siyang conflict. Now, assessing all of the options that we have, depende doon sa ating design and goal or doon sa context ng problem kung alin dito yung gagamitin natin. Again, primary consideration natin is yung constraints. So, let's have here some example. So, we have your president. Attribute niya is name, party, term. Appoints cabinet member. Ang attribute naman niya is name, net worth, and office. And then this cabinet member has relationship to task. We have relationship type has. And ang attribute ng ating task is description, which is a partial key, priority, and duration. So to translate this, first let's create a relation for president. So we have name, our primary key, party, and term. And then let's create a relation for our cabinet member. So we have here name, net worth, office, and then since this has a one-to-many cardinality with the president, we will copy the primary key of president as a foreign key in cabinet member. Since the cabinet member yung many yung cardinality. So tapos na tayo dito sa relationship na appoints. Now let's move on to the other relationship, the has. So this task, this is a weak entity. So to represent this, we'll create a separate relation. We have task. And then for the keys, we will add the primary key of the strong entity it depends on. So we have your description and then name, which is the primary key of cabinet member. And both of these keys will be the key of this relation. The partial key of the weak entity and the primary key of the strong entity depends on. And then, copy lang natin yung ibang attribute. We have priority and duration. Now, our next problem, we have your drug lord employs drug pusher. And then drug lord pays drug pusher. And drug pusher sells drug. So let's try to model this as a relational table. So first, let's create a relation for drug lord. And then we have your alias as our primary key. We have name and coverage. So yun lang yung attribute ng ating drug lord. And then we create a relation for drug pusher. So name, which is our primary key, age, and since this has a one-to-many relationship with the drug lord through employs and pays relationship type, we will just add the primary key of drug lord to the relation of drug pusher as a foreign key. So we have your alias in italics. So this foreign key will represent both the relationship employees and pays, since parehas naman silang one-to-many. And then let's move on to drug pusher sells drug. So first, let's create a relation for drug. So ang ating primary key will be drug name and then other attributes, price, and quantity. And then we have here a many-to-many relationship. So ang rule natin, we will create a different relation if it's a many-to-many relationship. So we have here cells, and then we will just combine the primary keys of both the entity it associates. So we have your name, which is the primary key of drug pusher, and then drug name, which is the primary key of drug entity. For our last example, we have your agriculturist examines plant. And then we have here a many-to-many relationship. So let's create a relation for agriculturist. And then for our attributes, we have name, which is also our primary key, location, and position. And then for plant, we have your scientific name, which is our primary key, location, variety, and common name. And then again, since this is a many-to-many relationship, we create another relation, examines. And then you will just combine the primary key of both entities. We have your name, which is the primary key of agriculturist, and then scientific name, which is the primary key of plant.